Well, welcome everybody. We'll start the webinar right now. Today's is March 12th, 2013. My name is Todd Maxwell, and we're going to be talking about understanding the log file and quick troubleshooting techniques. So we're going to go into some of the topics of the DSS v6 or v7 download log file. What is in the log file? What main logs do the OpenE support team review? So typically we have a procedure that we go through when a certain question is asked or when there's troubleshooting techniques that need to be applied. So we also look for search for history events and why is it important to remove the logs after downloading the log file. Many times you have asked, engineers have asked you, probably customers, to find out, once we receive the logs, please remove the logs so we have fresh logs. That's why it's a real helpful advice that we offer you to remove the logs once you get logs so we can start capturing more information. Normally I don't give out PowerPoint or presentations of lengthy time because I like to show real events in real life, but this probably needs to be addressed and reviewed with everybody so many people could take notes. So I'm going to go over these screens, so just bear with me. I think they're important and it'll give you an idea how you can troubleshoot logs and get an understanding which log files you're really looking at. So with DSS v6 and v7 system logs, and what do they, why do we need them? Well, the logs contain information of the DSS v6 or v7 system, and they help to troubleshoot issues. This is where you're going to start seeing some of the things and techniques that we use so you can learn from us. They provide also information on how the system behaves, and they point to bottlenecks and in order to make some tunings. Also, where are the logs? Pretty much most of you already know, but I just thought I'd bring it just in case somebody doesn't, is that they're downloadable from the GUI. So if you go to status, hardware settings, and then of course you'll see the function for logs, and there will be a download button to click on, and that'll download the whole log file. Now it takes a few minutes, so give it some time because it's doing some commands, especially the test.log, and that takes time to retrieve all this information. And remember, there's hundreds of files in that log, and they're compressed in a gzip or a tarball. They can be unpacked using 7-zip or WinRAR. I'll be using the WinRAR in this demonstration. One of the main logs we look at is the critical error logs. This information is really vital. It's also noted that if you look at your event viewer in the DSS v6 or v7 on the bottom left of the GUI, you'll see the event viewer. Some of you will see it as, most of you will see it as an envelope, a yellow envelope. And so you want to be able to click on that and it'll give you some information, but that's coming from the critical error logs. It includes timestamps of the logged events. We're going to go over some critical error logs to troubleshoot and diagnose together and give you some ideas of how we do the troubleshooting when we see these critical error logs. Also, the DSS uses the system syslogs or the smart expressions for filtering messages, and also if you configure the DSS v6 or v7 for your email, you'll receive these critical error log events as well. So it's pretty important for you to set up your email so that way you receive these messages. So that's the critical errors logs. Now let's look at the D message and the D message 2 logs. What you'll commonly see, they're also compressed sometimes for historical events. The D message, which is considered the display message or driver message, and it displays the contents of the system message buffer. So each device driver that is present in the kernel, what it'll do, the kernel will probe the system for the existence of any relevant hardware. Now if the hardware is located, a diagnostic message is produced documenting precisely what is found. We'll be demonstrating that as well. It can detect things like so-called I/O errors, which are pretty critical in what we see in the support tickets with the attached disk or the RAID units. We would also see issues with NIC cards or any iSCSI messages, even down to any call trace errors. So we will go look at those in just a few minutes. The test log, we really use this as well. What it does is it divides it into many sections. They're basically named respectively to the command that is generated from the output that we do for the internal self-test command. This log this takes the longest out of all the log files because once you open up a test log, you'll see a plethora of information there. So it'll include information from the system and other processes, provide benchmark results for the read performance of the disk and RAID units. You'll be able to see the volumes with the relationship to for your SATA devices, for SDA, SDB, and so forth, and also your logical volumes. So you can see your NAS logical volumes, iSCSI, snapshot, and fiber channel. And it can also find the firmware for the RAID controllers. Also, it can be also found in the dmessage log as well for the firmware. A lot of times we catch firmwares that are out of date, and we recommend customers to update the firmware. This helps because of the drivers for newer versions that are in DSS v6 or v7, that you want to keep them relatively close to each other with the firmware and the latest drivers. So let's take a look. Here we have an example of a RAID unit and disk I/O errors. And we found this in the dmessage log. If you look at the green arrows, the top arrow is pointing down to SDB. So here we have an error message, buffer I/O on device SDB. And basically, and profuse apologies with the arrow being messed up on the bottom there, but what that means is that we have an error on the SATA device B, so we would have to track that down. You could tell that this is an HP RAID controller. On the left, you'll see the CCISS controller. And on the bottom, where the arrows is covering that line, which was misaligned, it's rejecting the I/O to an offline device. So here we have a very serious issue. Either the RAID controller and the connection to the drive, or the drive's having an issue. This can cause a problem, so we want to be able to help you investigate that, locate the problem. If you have multiple arrays, SDB, there might be an SDC as well as an SDD, and a lot of times there's more than one array in a single DSS system. So this helps us and helps you to pinpoint where the exact location of the problem is residing. Here we see sometimes a call trace errors, and this can also be what's called a journal commit I/O error. This can be found in the critical error logs, also in the dmessage log as well. Here we have probably a serious issue where what's probably recommended here is we need to check the RAID health, and then what we need to do is, let's go back to that screen, profuse apologies. We probably want to be able to check the RAID health and then run a repair file system. And that's located in the extended tools, but you really want to check your RAID health first, make sure all the drives are intact, that the RAID is finished rebuilding, or it's done a health check. Then you probably want to run the repair file system, which is in the extended tools from the console screen. Sometimes we get cases where the customer will state, I'm receiving intermittent problems with communication of my network, or it could be the switch, or it could be maybe a bad NIC. Sometimes we have to investigate this, and we locate it in the test.log under the ETH tool section. Here you're seeing bad packets. So, if your system has been up, let's say 5 minutes or 10 minutes, something will drop packets, and as you can see, it's from the RX side, the receiving side. TX is for the transmit, so that would be coming out of the DSS v6 or v7. So here we could show you where that would be located in the test.log. You also get information of the MTU value. As you can see, it's set to default 1500. That's your jumbo frames. But typically you want to look at these, and you can also see these pretty much live as well from the console screen under the Control-Alt-N. If you go in there, and you'll see your listed network interfaces, and then you select that NIC, and then what you'll do is you go to the right where it says info. There you'll get the same display output as you're seeing here. Again, we get cases where we have customers send in a ticket, the performance is really poor. We find out that the issue is residing with the NIC, and we find again in the test.log in the ETH tool that the speed has been reduced, and so here you see 100 megabits. Well, obviously, and it's half duplex, which is even worse. So a lot of times we find out that usually there has been a change in the network, or maybe the network engineers have came in and did some changes, moved some NICs to a different port, and we will detect that, and we'll also point this out to you as well, usually on our support tickets. All right, so let's take a look at this log here. This is coming from the dmessage log. And what we're seeing is a customer will come in and say, I'm getting poor performance. What we have typically see is the write cache is disabled. You see that SDB write cache is disabled. Typically, normally the read cache is enabled on most of the controllers that are out there. But in this case, this RAID controller, the customer did not set the write cache to enable. And you're going to have a performance decrease. So you'll be able to detect this also in the D message log where we can investigate that. So you could do the same thing as well. All right, so let's look at some logs. Let's go ahead and shrink this down and let's bring up some logs that I have collected for us. One of the first ones we're going to look at is the adaptic. Here we will open it up. I'm using the WinRAR. And at first you can be pretty much blown away by all the files here. So don't worry about it. That's what this session is about. We're not going to be able to cover everything, as you can tell, because there's a lot of information here. It would take me many, many hours to go over all of them. But I think what we're going to be able to do is learn from what we have. So here I have a customer. He states that there's a problem with his performance. Also, he's having intermittent errors. So one of the first things, just like what we talked about, let's look at the critical error logs. You can see here it's critical_errors.log. So I'm going to right click and view it. So obviously we have a problem. As you could see right here, right on the top, it's screaming at us, I/O errors detected on unit S001. Probably that would be VG01 because S000 would typically be VG00. So we know that there's two arrays in here. Obviously, the notation here, the unit requires your urgent attention in order to decrease the risk of data loss. Now, right below it, you're seeing error, no system volume found. So he could have possibly made the S001 be the default system volume or default volume group, which commonly can happen. Usually engineers swap out arrays or they're doing some events. But if we look down lower, here we see I/O errors detected on S000. So we know that probably this could be related to the issue of their system is just not able to detect the RAID controller. And if you're doing them live, and if you see this live, you'll be able to detect that through the logs. Now, let's go ahead and take another instance here, and let's go to another log, and let's look at the dmessage2 log. So as we scroll down, you can see a lot of information here. You're seeing the USB, a lot of the power management features here. We're picking this up from the display messages. So let's scroll down a little bit more here. So just bear with me because there's a lot of information. And obviously we see the adaptic array right here. So we've got the array 1. And then of course we see the other adaptic array 2. And then of course, if you notice, SDB, his write cache is disabled. And also on SDA. Now, some engineers don't want to use the write cache. They don't want to enable it. They may not have a battery backup unit attached to the RAID controller, which in many cases you don't. But you really, if you can, get a battery backup unit and then be able to enable the write cache, and that'll get your performance. If you look below, we see that we have the Seagate, the drives, and the type of drives. So we can research information. We also see we're getting some other weird messages right here, SDA. And we're seeing that the limit is trying to access beyond the end device. So this tells us we got a problem with the adaptic RAID controller. If we scroll down a little bit more, we see that he installed the DSS on a USB flash stick. It looks like to be about 4 gig right there. So let's take a look at, maybe you can find some information on the adaptic RAID controller and find out exactly, to help this customer out, what his problem really is. If we scroll down, adaptic, each RAID controller provides each of their different log values. So here under adaptic we have the RAID event A.log, and this basically provides us information. So let's take a look at it. Alright, one of the first things you're seeing right here is one or more logical devices contain a bad stripe. So this is a real serious issue. For this customer, he had to contact the adaptic vendor and get their support team to work with him. So again, this helps you see how we track it. So we first go to the critical error logs, then we go from the D-message logs, and then we go hunt for the RAID controller logs. All right, so, and again, you can use the Adaptive Storage Manager to collect information from their logs as well. All right, let's go take another look at another log. Here we have ADS and NIC and speed issues. So ADS is Active Directory Services. One of the first things we want to do, again, look at the critical error logs. This is what the engineers at OpenE do. So let's scroll all the way down till we find the critical error logs. Let's go to View. And as you can see, it's screaming, cannot renew the Kerberos ticket. Commonly what happens here, when this happens, either the gateway or DNS has been changed on the DSS side, so it cannot communicate with the ADS server. You should have in the DNS settings in DSS, you should have that DNS IP address pointing to the ADS server. And we could troubleshoot that real easily. Basically, obviously as we scroll down, this is a major issue. As we look at the date here, it's staying the same all the way through, and every second it's just trying to communicate with that ADS server, and as you can see, it's just not happening. So let's take a look at another log to see if there's any issue. Let's look at the test.log and see if there's maybe some performance issues with the NIC. Maybe the NIC is bad. So let's verify that first before we rule out that it's a misconfigured IP address. So what we want to do is look for the test.log. So let's scroll on down. Again, by the way, this is a three-way array controller. You could tell by the TDM markings, that's the RAID controller's log. In fact, we'll come back to that in a little bit. But let's look at the test.log. Here we go. All right. Now, the test.log is very, very big. So we're not going to be able to scroll down to it, all of it, because when I scroll here, you could see there's just a plethora of information that just goes on and on, but it's very detailed, and for us engineers, it's important because we're trying to collect as much information as possible. So I'm going to go take us right on down to what's called the ETH tool. So I'm going to go to Find, and let's go ETH tool, and it takes us right down to the section. So here, one of the first things I noticed that this network interface ETH0 is running at 100 megs. So typically I don't see that unless it was back in 2005. There might be some still out there, but for servers that doesn't look right. So there could be some kind of change that was in environment. Here we see these NICs are off, so there's probably nothing plugged into it, so they're not doing any functionality. Well, here we go again. We have another NIC at 100 megabit. So this could be maybe a performance issue that he might be experiencing, dropping off. We don't know. Let's find out. So we know that ETH0 and ETH2 are performing at 100 megs, which doesn't really make sense. So let's keep going. Now, obviously, the ETH3, there's nothing plugged in, nor is ETH4. As we see, ETH5. And now we go to the ifconfig. Now here in the ifconfig, here's what we can see for any receive or bad transmit packets. Well, there's no bad packets, so since ETH0 and ETH2 are the only ones online, you could usually tell by who has the most transmitted data. This is less, because this is in kilobytes, or this is in megabytes, so they're transferring most of their information here on this NIC. So it is performing at 100, which doesn't seem right. And we can see his IP address is in a 10.11.22.30. So maybe it could be something misconfigured for his ADS settings. Well, what we would do here is then go look for a unique directory called www. Here, this information provides us where we want to go into the setup and NAS settings. And here there's a log called authentication settings. So let's take a look at it, .conf. We see that the method for authentication, usually you'll see normally in DSS the internal LDAP, external LDAP. Here the method is using ADS. So if we look, we have the ADS server is a 10.0.0.55. So what we need to do is make sure that the DNS settings in DSS is pointing to that IP address, which is the ADS server. Let's find out. So what we do is let's get out of here, go back where we were before, and we're going to be looking for the net.com file, which provides information of the NICs. So if we scroll on down, we're looking for the net, there we go, .com file. So this is for the network interfaces. And here we could see that no, the DNS settings in DSS is not 10.0.0.11, which was the ADS server, and obviously this is their problem, and that's why the Kerberos cannot renew, because it doesn't have the proper DNS settings. So we would advise the person to change their DNS settings to match those for the ADS server IP address. So that's one technique that you're looking for the critical error logs. You're also looking at the, oh, and I wanted to show you the D message log. So let's go up because I wanted to show you the output for a three-way array controller. So again, this is the D message log. We're displaying the hardware devices here. As we scroll down, we could see that the DSS is installed on a Kingston USB flash stick. I want to remind everybody, you probably want to use SSDs. They have a longer life. They're relatively inexpensive now. So they're worth buying. They have a 5-year lifespan and a warranty. So I've just seen great reviews about them. So overall, you have less worries. I've seen more USB flash sticks fail. So let's scroll on down until we get to the three-way array controller. So you can see there's a lot of information. Don't let it confuse you. And here we're looking at the three-way. We can see his firmware is at a 4.10. .xxx, as you can see, so we can verify that if the customer may need to update it for his three-way 9690 SA version. Here he does have the right cache enabled, which is good, so he's getting good performance. And we can verify what his performance speed is. If we look at the test.log, let's take a look at it for SDB. So that looks like his SATA device. So let's go ahead and get out of the D message, and let's go all the way down to the test.log. And here we are. And what we're going to look at for is HD param, so which is basically hard drive parameters. And here we go. So here is the, he was SDB, I believe, and here we're looking at his Kingston. This is where the DSS is installed. This is the read performance output. And obviously this is much faster than his USB flash stick, so you could see that his three-way array controller is performing at this value. So that's a good log to look at for testing, especially for performance. You can also do this in the console in Control-Alt-W system benchmark performance test, and you could do the read-writes performance test as well for your RAID array. Okay, let's look at another log. Let's take a look at, here we had a customer, he was complaining that he couldn't connect to the GUI on the DSS V6 GUI. And what we find out is sometimes he would connect and he would not be able to connect to it. Well, one of the first things, again, we want to look at the critical error logs. So let's take a look at the critical error logs. Here we are. Right now we're going to be digging for something that's in the latest date, because we see that these are time-stamped. Remember, from the critical error logs from the beginning of the presentation, everything's time-stamped. So here we're looking for the latest date. So typically what we do is we scroll down to the latest date a little bit faster. So as we see, it looks like the problem is right here. So warning, your IP address x.x.x is in use by another network client. So obviously we have an IP conflict. So as we all know, that this can cause issues. So now we advise the customer there's another network device that has the same IP address that's on the DSS V6 or V7. So we advise him. Once he did that, his problem was resolved. So again, critical error logs really helps identify immediately how and where the problem could be. Okay, let's look at two more and then we'll be done. This is about the NIC and D message and test log. So what we want to do is just kind of review on this one. There was an issue with a network, so let's find out. Again, let's go to the critical error logs. That's the first one we want to start with. So let's take a look at it. Nothing there, so let's dig a little deeper. Customer said he had some intermittent problems. He doesn't know why. Sometimes they don't even tell us why or which NIC it is. So let's go look at the critical error logs. Let's find out if it's in the D message. Maybe something in there in a D message can tell us something. Wow, as you can see, yes there is. It looks like Ethernet 7. If we look here, E7 has some real issues. The link is up and then the link is down. And that is consistently all the way down through this whole log. So obviously we have a major issue with that NIC E7. Probably it could be some problem on the motherboard. Maybe there's a problem with the cable itself. I know it's very rare that we all see dead cables, but something is causing that network interface to go up and could go down. Maybe could he possibly drop bad packets? I don't know. We can check. And we can check that through the test.log. So in DMSs we're seeing an output. Something going on with that device is having issues. So let's look at the test.log. Maybe something's in there that might add more information. So we'll scroll all down to test.log. Let's find it. Here we go. And as you can see, there is a lot of logs. There's a lot of information you can get. So again, it's a long scroll down list. So what we usually do is go directly, we'll go if config. And it takes us right down to the if config section. Now that was NIC 7 or ETH7. Here we look at the other NICs. It doesn't seem to be any bad packets. These jumble frames are all set to defaults here that I'm seeing. There's no bonding. Normally you would see a bonding right here, bond 0, then bond 1, and you would follow the MAC address to associate which bond NIC that it is bonded to. So let's go all the way down to ETH7. Let's see what we have here. Okay, I'm not getting any bad packets, nor is he transmitting really very much any data. So I would pretty much suspect that we probably have either a bad NIC, and I would inform the customer to check the cable or put a new cable, new switch port, and then also to verify if that NIC is properly operating right. Maybe do a direct connection from the motherboard to the PC to see if there's, and run a test to see if it's still going up and down. And so we advised the customer of that. Apparently we did not hear from him back, so apparently it was either the NIC changed to a switch port or he changed out the card, because that looks like an add-on card, so it looks like they had a 4-port NIC card there, so maybe one of those ports are bad. Now let's look at this one. This was a customer that basically he was not able to see his volume. It totally went offline, which is critical, as you will all know. And when he sent he couldn't identify really. We figured out what it was. And the first thing we do is, again, we go to critical error logs. If you notice, we even compress them here because we keep them, they can be overflowing, so we compress them each time. And also each restart. So it looks like this customer had 2 restarts. First thing, I know I'm saying this again, we want to be able to look at the critical error logs. And here we see a lot of uncompressed critical error logs that are about to be compressed again. It looks, because it maxes out over 60K bytes. So here, let's look at it. And wow, you could see that there is a lot of I/O errors detected. And of course, we put the note, to prevent data losses, recommend to shut down the system, contact your hardware vendor, and to investigate. So we have a lot of I/O errors. I don't know what's going on, so let's figure it out. Let's find out where's it coming, how's it coming. So let's take a look. So that's the critical error logs. Now let's go take a look at the dmessage log. Maybe we can find something out about the devices. So if we look in the dmessage.to log, again, you can see we have buffer I/O errors on the device. And we have, it looks like to me, the SATA device A. And that is critical. So it sounds like it's trying, and it's returning errors. It's trying to force its connection. So usually either we have multiple devices that are bad, maybe connectivity is bad, maybe the RAID controller is resetting itself, so it's not communicating, it's sending back the message back to the OS, which is our operating system, to be able to fulfill the logical volume manager needs. So maybe we can tell him possibly he needs to check the cables, he needs to check his RAID controller, maybe reseat it. Let's find out what SDA is all about and find out where more information we can find in the test.log if he's available or not, if the OS is trying to pick up any information. So if we scroll on down, let's look at the test.log. And let's go to what's called VG display. So it means volume group display. And it looks like the whole volume is offline. So at this case, we would probably recommend, because normally what you would see, since it was SDA, this is SDB. This is where DSS is installed. You can tell by that the system is on a FAT32 format. You can tell it's also by its size, by a 1 gig size, and that's typically what the DSS V6 and older V5s were installed on. But the volume group is gone. Normally you would see all the logical volumes, and they're not being displayed at all. They're only from cached and backed up that we know of, but they're not active and online. So in this case, we'd recommend the customer to go ahead and be able to verify the cables and verify the drives and maybe the back plane or the motherboard is having problems where the cards or the cables connected to the devices or to the RAID controller card itself. Well, that's just about it, because we can go on and on about logs, and this is where it's just it can go on forever. And I want to thank everybody for showing up at the webinar. We are thinking about doing more log webinars and more documentation of it, because it's really helpful, especially for engineers that are out in the field, especially for after hours and you really want to diagnose the problem or just to be savvy. Either way, it's always good to know logs. Take care. See you next time. Bye-bye.